In this video, I'm going to show you how to solve 4 hard SAT math questions. But before I start the lesson, I want to be totally honest with you. If you're looking for a video that breezes through a solution for the latest hard SAT math question, this is not the right video for you. If you're looking to gain a significant advantage over any hard SAT math question, then spend 10 minutes of your time watching this video. It's full of detail, nuances, and it's a little bit painful, but in a good way. And it's exactly what you need to get the score you want. Let's take a second to see what's going on with the prepping you've done so far. These are graphs of SAT score improvement for the average student, and they're modeled using data directly from the College Board. Notice the curves flatline at 21 hours of prepping. If you've prepped a lot and you're experiencing the same trend, it tells me 2 things. 1, you have the math you need to get the hard questions right. And 2, however, your approach to hard questions, well, it could use a little work. If you haven't done a lot of prepping, then watch this video so you don't have to experience the same thing that everyone else is experiencing. Here are 2 hard questions. Which one do you think is harder? The one on the left or the one on the right? Most students would pick the one on the left, but we're going to work through both and see how they play out. Let's start with the one on the left. As I read through this problem, I see we have a triangle with a base, a height, and an area. And then I see that all 3 of those things, base, height, and area, are going to be changed by percentages. So I think we should start by writing the formula for the area of a triangle. And there it is. 1/2 base times height is area. The next step is, since the values of the base and the height are going to be changed, I think we should insert those in there and just see where it goes. So we pop those in, and then, we can calculate the area of a triangle very easily. Now, had you not written the formula in the first place and had you not put those in, you might not have noticed this. The next step is we're going to be changing all 3 of those things by percent changes. So we need this formula here. And then what we're going to do is we're going to stack those into the equation. So the next step, we're going to stack those in, and there they are. And then I'm looking at what I've got now, and what I see is it's a very messy, busy equation, but I have 1 equation, 1 unknown. We can just pop this into Desmos and let it do the work. So let's do that. So there I am, typing it in. And then don't forget to change the equal sign into a tilde so we get a value out. And then there's the value. At this point, we've done a lot of the work, and it's very natural to get all excited about this beautiful round answer that we have. But there is a final step. It's really important to reread the very last part of the question and make sure we're giving them back what they're asking for. They're asking for P, we found P, great. So they're asking for P% or 100 times P or anything else. So we're done. Now let's look at the problem on the right. The first thing I notice is there are 9 lines of text. And then there are bizarre technical terms and a crazy formula. To me, this is good news, because normally what it means is the problem actually isn't that hard to do. All you gotta do is dial in on the few parts of the problem that you need to get the job done. I usually start with the equation. And when I'm looking at the equation, I see an R and I see a P. And I see that we're trying to find P, so obviously we don't have that. So what's R? So I read down below and I see that, it's the only number I got is 6.25%. And what is that? It's a decrease in the beam's triangular cross-section area. And I look right above and it says the beam's triangular cross-section area decreases by R%. So R% is 6.25%. So I'm going to rewrite the 6.25% as 6.25 over 100 because I changed it into a number. And then the R is the 6.25. So I load that into the equation, and what do I notice? I notice I have 1 equation, 1 unknown. That means I'm just going to type it into Desmos and let it do the work. So here I'm typing it in, and then don't forget to use a tilde instead of the equal sign, and there's my answer, 25. The final step, as always, is to reread the final part of the question and make sure you're giving it back exactly what they're asking for. What do they want? They want P. What did I find? I found P. Good, we're done. Now that we've done these 2 questions, I'm going to ask you again. Which question do you think is harder? Next, did you notice the 2 questions are similar, but at the same time, very different? Just watching me work my way through these questions isn't going to help your score improve much. But if we now compare these 2 questions side by side using the 3 perspectives I'm about to share with you, your SAT math score will grow dramatically. First, the SAT mostly measures reasoning and problem-solving skills in 2 areas. 1, of course, in math, but with a limited number of math concepts and formulas. And 2, in these test question design elements. Let's see where these design elements show up in the questions we just did. For the question on the left, the first thing I notice is big time layered reasoning. First, you have to read the question and interpret it. Second, there's not just one concept, there are multiple concepts. So you got to use geometry, percents, algebra, and Desmos. The second thing I noticed is abstract representation. So there's a lot of information in this question, and it's just all words. There's no drawing, and there's no organization of information. Do you remember back in elementary school when they taught you problem solving? And they give you a word question, and they're like, okay, so make a drawing, make a table, organize the information. None of that's been done here. So that makes this a rather abstract question. The third test question design element that I noticed, and it's pretty clear, multiple steps under time pressure. And now let's look at the problem on the right. The first thing I noticed is disguise simplicity. I mean, there's all that stuff, and in the end, all you needed was R and to use Desmos. Clearly disguise simplicity. The second thing I noticed about the problem is the distractor trap. They give you R%, but in the equation you need R. The second perspective is that the SAT severely limits the number of math concepts and formulas for two reasons. One, the test is short and the writers want you to focus on reasoning and problem solving. And two, they don't want you to miss a question just because you didn't know a formula. What this means to you is that you don't need this math concept and formula toolbox. Instead, you need this one. Now let's take a look at the math concepts and formulas we needed to do the last two problems. Here's a list of the math concepts and formulas we used to do the last two equations. If you know all of them, you can get these questions right, even though they're hard. With the first question, we built an algebraic equation from the given information, and we started by using the formula for the area of a triangle. Then we used basic percent knowledge to change p% into a number, and we inserted the percent change formula into our algebraic equation. And finally, we used Desmos to evaluate our equation. But in question 2, even though all 5 concepts are baked into the question, we only needed to use 2 of them to get our answer. We used basic percents to change R% into a number, and then we used Desmos to evaluate the equation. The third perspective is that the SAT is designed so you experience STS while reasoning and problem solving. STS is stress, time pressure, and high stakes. Let's suppose you can solve SAT math questions at home, no problem. But on the real test, you struggle. Then you've experienced STS. How do you overcome STS? Let's suppose you're working through a practice percent question and you get it wrong. Doesn't matter what the reason, you miss it. Then find every percent question in the digital SAT PDFs. Then, using what you've learned here, carefully read each question, comparing and looking for patterns. Now try this. Pause the video and work through these next 2 hard questions on your own. You're working through them, of course, to get the right answer, but focus on using what you've learned here. Then when you come back, I'll walk you through my own thoughts on these questions. The first thing I noticed about question 3 is it's less abstract than question 1, so the SAT writers would consider this easier. The reason it's less abstract is the given information is organized into a table. I'm going to go ahead and quickly set this one up. We have 2 triangles that have areas that are related. So I'm going to write the area formula for triangle X, and I'm going to load in my values, and I get A is 24. Okay, and that's kind of a dead end there. So now I'm going to move on to triangle Y. I'm going to set that one up using triangle area formula. So I'm going to load in the lengths, and I have that that's equal to A. Now they don't give us A in the chart, but the words below give us the information we need to construct it. And basically triangle Y, the area is 6.25% less than triangle X. So I'm going to write in the area of triangle X, insert the percent change formula with the 6.25 in there, and now I'm good to go. I have an equation that's the exact same one as question 1. I just insert into Desmos and evaluate it. The only difference between question 1 and question 4 is question 4 has a drawing and it has a distractor trap at the end where it asks for 5p instead of just p. The numbers on the drawing are the same as the numbers in the sentence. So the only purpose for the drawing is to make it easier for you to visualize. I'm not going to bother working this out because you could actually do the problem without even having the drawing, and then it is the same problem as question 1. At this point, you might be wondering why no one else is teaching this. I have a unique perspective that comes with a lot of highly specialized experience. Over the last 30 years, I've helped thousands of students raise their SAT math scores. As a math education consultant, I help schools troubleshoot their standardized tests and help their teachers improve their student math performance. On top of that, I've written thousands of pages of math curriculum, and I am a mathematician. If you have any questions, leave them in the comments section, and I will do my very best to answer each one of them.